Hello everyone, welcome back. In this video, we will see what is a dangling pointer in C programming. A dangling pointer is a kind of pointer that points to an invalid memory location. It might be possible that a pointer previously pointed to a valid memory location, but if the memory is now deleted or unwinded and pointer is still pointing to that invalid memory location, then it is a dangling pointer. Basically, it is a pointer that is pointing to an invalid or de-allocated memory location. This can occur when the memory that the pointer was pointing to has been deleted or de-allocated from the stack, but the pointer still holds the reference to that memory location. In such scenarios, we refer to the pointer as a dangling pointer. Dangling pointers are important to identify because if we try to access the value at the memory location through a dangling pointer, it can result in an undefined behavior. It may crash the application or produce invalid or unpredictable results. Therefore, it is crucial to identify and handle dangling pointers in our code to ensure that they do not exist in our application. In this video, we will discuss 3 different scenarios that can cause dangling pointers. Let's see them one by one. First scenario: de-allocating memory and dangling pointers. The first scenario that can cause the creation of a dangling pointer is deallocation of memory. Suppose we allocate some memory on heap using the malloc function and assign the location of that memory to a pointer. After some time, we delete the memory by calling the free function. Now, after this line, where we have freed the memory using free function, the pointer still points to a location where the memory has already been deleted. This makes the pointer a dangling pointer. If we try to access the value using this pointer, it can result in undefined behavior. To handle this scenario, it is essential to assign pointer to null after freeing the memory. Once the pointer is assigned to null, it is no longer a dangling pointer. This is how we can identify and handle dangling pointers when deallocating memory on the heap. Second scenario: function call and dangling pointers. Let's discuss the second scenario, which is due to stack unwinding after a function call. Take a look at this example. Here, we call the function getValue. Inside the function, we allocate a variable on the local stack and return its pointer. But as soon as the function returns, the local stack of this function gets unwinded, and the memory to which the pointer is pointing becomes invalid. Here, the pointer ptr is pointing to a local variable of the function that is out of scope. This makes the pointer a dangling pointer. If you try to access the value at this memory location, it can result in an undefined behavior. It can cause the application to crash or give unexpected results. To avoid this scenario, we can either not return a pointer from a function that points to a local variable, or we can make the local variable static. In the latter case, the scope of the variable will be at the program level, and once the function returns, the memory it points to will not be unwinded. Thus, we can safely use the pointer because the memory is still valid. Third scenario, code block and dangling pointers. Now let's discuss the third scenario in which dangling pointers gets created. Dangling pointers get created when a variable goes out of scope, but a pointer is still pointing to the memory location of that variable. Consider this example. In the main function, we have created a separate block. When we create a separate block, the scope of this block is different from the main block, and so will be its stack. When this block exists the scope, the memory on this stack will be deallocated. In this example, the memory of variable value will be unwinded from the stack when this block ends. So, the memory to which pointer ptr is pointing will be deallocated. Therefore, the pointer ptr, which stores the address of the memory location from the stack of this block, becomes a dangling pointer because the memory is now invalid. If you try to access anything using this pointer, it can result in unexpected behavior. So these were the three different scenarios where we can encounter dangling pointers in C programming. It is important to handle dangling pointers properly in our code, otherwise our code can produce unexpected results or crash during production. So, in this video, we discussed what a dangling pointer is and why it is important to identify them. We then explored three different scenarios where dangling pointers can be created in our code. In order to have a better understanding, let's rediscuss them. First scenario occurs when we allocate memory on the heap and deallocate it without assigning null to the pointer. In this case, the pointer becomes a dangling pointer. The second scenario arises when we call a function that returns a pointer to a local variable. Once the function exists, the local variable goes out of scope, making the pointer a dangling pointer. The third scenario involves assigning a pointer to a memory location inside a block. When the block exists, the pointer still points to a variable or a memory location that has been deallocated, resulting in a dangling pointer. So these concepts and information is applicable to both C and C++ programming. We hope you found this video helpful. Thank you so very much for watching the video and please do not forget to subscribe the channel.